Good evening, everyone. So, on behalf of the System Society of India, Thiruvananthapuram chapter, it's my pleasure to welcome you all to our talk series, Blending in 20. So, we are honored to have with us today Sri Sheeju Chandran, who will be speaking on the fascinating and forward-looking topic, human habitats beyond planet Earth. Sri Sheeju Chandran is currently the Group Director of the Technology Development and Management Group at Vikram Sarabhai Space Center, a mechanical engineering graduate from the College of Engineering, Trivandrum, and holding master's degree in aerospace from the Indian Institute of Science, Bangalore. He is a multifaceted individual with expertise that spans beyond his professional career. With a remarkable career at ISRO, he has contributed significantly to various disciplines, including Space Ordnance System and the Human Spaceflight Project. His outstanding contributions have been recognized with ISRO Young Scientist Award in 2008 and High Energy Material Society of India Young Scientist Gold Medal in 2017. We extend our gratitude to Sri Sheeju Chandran for taking the time to join us and for sharing his valuable insight on this exciting topic. So without further delay, let us begin this session. Thank you. Sir, Sheeju sir.
Hello.
Yes, sir, you can start presenting.
Yeah. I hope I am audible.
Yes, sir.
Yeah. Let me just share the screen. Is the screen visible?
Yes, sir, visible, sir.
Yeah, fine. So I will stop precisely at 8:21. Okay. Now the topic is self-sustainable human habitat beyond planet Earth, and we all basically know what is a habitat. So a habitat is a natural environment where an organism or a community of organisms lives and survives. And this, whatever we call as habitat, it will provide this living things with food, shelter, and space, and all these comforts. And basically, human beings also, if you take, we are the product of the habitat, or not the other ways. But unlike many other organisms on Earth, we, the humans, have been able to create and control habitat to a great degree. Today, the humans can create its own habitat. It can destroy its own habitat with the technology, with the skill set which it has acquired over a period of thousands of years of evolution. And if you see the history, you know that the first living things on the planet Earth has been made its first appearance around 3.8 billion years ago. And we are all aware that the Earth itself was formed around 5 billion years back. And from 2.4 billion years back, there was something called a great oxidation. So the carbon dioxide rich atmosphere was gradually getting transformed into an oxygen rich atmosphere by what we call the cyanobacteria. And then from 2.1 billion years back, we started having clear evidence of photosynthesis. And as late as only 6 million years back, the first humans, that is the forerunner of our humans, the biped humans, have started being or started its appearance. And if you see the history of humans themselves, if you see, we started our active life as hunter-gatherers. People are moving around, killing animals and eating. And when we had the first agriculture, that is, the humans could settle down somewhere and then they could start having what we call the civilization. That is, they could get a lot of free time so that they can think, they can create tools, they can add more to their value to their life. This is basically what we call civilization. Then subsequently, there are different periods of our human evolution called the age of discovery, where we developed technologies. Then we had what we call the age of exploration. People started moving around, crossing seas, conquered space, and today the extent of which is extended to even what we call interplanetary migration. That is basically something to do with this topic of discussion. The reason why I told about a brief history of our evolution is, even today, our whatever we had gone through is still in our in our genes. And that decides how we think and how we actually plan for our future, how we basically takes care of the risk, etc. Now, if you're so comfortable on Earth, why we actually have to go to other planets? What are the basic arguments? The biggest one is, or the strongest argument is the existential threat that we'll subsequently see. In addition to that, there can be other corollary kind of reasons, like there is a population growth, there can be resource scarcity, the human beings basically are exploratory in nature, they want to innovate, and then we have economic opportunity, and then there are a lot of other things which are characteristic humans. But the strongest argument will be there can be a potential end to the human survivability on planet Earth. So in that case, you have to go to other planets or other areas to survive. And if you see the probable causes and their likelihood, asteroid impact, we all know it's a real threat. The life have been nearly wiped out earlier. We all know the case of 65 million years back, the Chicxulub kind of asteroid impact, where almost all the dinosaurs were wiped out. And even today, this is a real threat. But this large scale extinction of entire life is unlikely unless the asteroid is more than 1 kilometer in diameter. But even if even if the strike is of a very small kind of an asteroid, it can basically erase the civilizations. Humans may be there, but will be thrown back to the Stone Age. Super volcano eruption. This is today may not seem to be a very active threat, but similar things have happened in the past. There is a very infamous or famous case of what we call the Mount Toba Lake or volcano eruption, which happened near Sumatra, that is Indonesia. So where practically almost all the humans were wiped out, hardly 35,000 or so survived. Then we know so many other cases. These are probably the natural scenarios where today humans have acquired a lot of methodologies, by which the habitats can be changed for the worse, and then it can create existential threat. One of them, of course, is the nuclear war. Then there is a climate change, mainly induced by the humans. There are global pandemics, both natural and some of them are engineered genetically. And then of course some of the recent threats which have come up and which have called for a lot of discussion is that of artificial intelligence. We have created robots, or we have created machines with intelligence, thought process of its own, and it's extremely likely that within a short span of time they will have the ability by which they may take probably control of the planet. It's really possible. So these are probable strongest argument if someone want to argue for life outside Earth. So if you want to go to somewhere outside there, what are the options? Of course, one is what you can have these orbital stations, but they are not really in a habitat because it's fully artificial. It is fully sustained by the communication from the Earth. There is nothing like what we call ISRU, that is in situ resource utilization. Very few people only can be supported. The two major candidates are the Moon and the Mars. The Moon, of course, we know it's very close to the Earth. We can have continuous resupply from the Earth. We can have in situ resource utilization. But the biggest threat is, or the problems are, there is no atmosphere, very low gravity, extreme temperatures, high radiation level. But still, Moon is a very good choice. Mars, it's far off, but again, it has got certain advantages. It has some atmosphere. It has got a day of Mars is somewhat identical to that of the Earth. Of course, there are other problems. Venus, we can consider as a candidate, but it's the condition on the Venus is extremely hostile. Temperature of the order of 400, pressures of the order of 660 degrees Celsius, and this atmosphere is fully with what we call sulfuric acid. So these are the major options. There are so many other which we don't consider. So if you want to see a short-term option for a habitat, Moon is a very good choice because of this proximity. Even if you have some problem in sustaining on the Moon, you can always supply it from the Earth. You know that hardly 3.5 days is what it takes from the Earth to the Moon. So Moon is a first intermediate choice. But midterm, of course, Mars is very good. And then long-term, other satellites of planets like Titan and Europa, they have got very strong claims to be a habitat. Now, any sustained human habitation, the sustained is also important because we are not just going there to go and come back. We basically are going there to colonize. The major issues are, as we have seen in the initial slides, humans have been adapted to the habitat or the habitats which created humans so that it can basically live and sustain. So we are used to 1G, we are used to the kind of environment what Earth is having. So wherever you go outside all these planets, we'll have difficulty in adjusting to the microgravity, we'll have problem with the radiation, then a circadian rhythm related issue. The biggest thing is there will not be any life support system at all. So there will not be any oxygen, there will not be any water, there will not be any kind of food materials, everything you have to take. And we are used to live in our own created infrastructure that, of course, will not be there. So you have to create. And then many of the risks which we have here on Earth, that will be there as well. For example, the space debris, the meteorites hits everything, economic viability, and so many things will be there. So when you're talking about sustained human habitat, there are so many challenges as well. Now, we have been having a habitat outpost for a long time. We know space stations are there, space stations were there, and still today space stations are there, and there are so many space stations plans for the future as well. So here we have developed such technologies, and humans have developed a lot of experience in operating space station, which will be very useful for sustained long-term options. Now, we'll just see one case, that of a Mars, and we'll throw a little bit more light on this particular aspect. So suppose if you want to colonize, if you want to make a habitat on Mars, what are the things you should do? Mars has got certain advantages over other potential candidates, because as I've told you, the Mars temperature is between say minus 55 to say 20 degrees Celsius. That's slightly on the lower side, but still it is much more easy to heat a planet than cool it. And then the one day of the Martian, when Martian day is somewhat 24 hours, which is somewhat identical to that of the Earth. And then we carbon dioxide, even though it's carbon dioxide, Mars has got an atmosphere. So that means there are resources in the Martian atmosphere. There is water on Mars, of course, in trace conditions, and it's not in very accessible form. But these resources will be greatly useful when we want to colonize. And on the flip side is, as we have mentioned, there are the low gravity. Gravity is only almost 40%. Then the issue of micrometeor and coastal environment. But still, Mars is a very good candidate, and let us see how it can be done. And if you want to make a case study for Mars, these questions you have to answer. One is how to reach Mars, how many people you have to take, how to create an environment, how you sustain life on Mars. This is relatively easy, how to reach Mars. Today, as you are aware, there are powerful rockets which can take a significant amount of payload to Mars. And every 26 months, the Mars-Earth alignment is favorable. And if you launch a launch vehicle once in every 26 months, that is what the Martian window, the travel time can be as low as say 6 to 9 months. So even then it's significant, but it is the lowest. And today there are a lot of vehicles which are capable of doing it. The downside is long flight through radiation belts, and then the cost. And now people have done some studies, and they have estimated at least 150 people or 100 to 150 individuals may be required to sustain a functional colony. And they have to have a lot of skill sets. They should be engineers, they should be doctors, they should be geologists, there should be psychiatrists and agriculturalists, and everyone have to be there to basically start a colony. And then how to create an environment. As you can see, in the short term, the humans cannot be supported in Mars, since the atmosphere is 95% carbon dioxide, and the pressure is less than 1% that of the Earth. So you can only live in pressurized habitats. That is, you should be living in bubbles, cocoons, where it will be pressurized and there will be significant amount of oxygen. And then you can do additional generation of resources by electrolysis of water extracted from carbon dioxide, extracted from Mars, and then a lot of things. We'll subsequently see in these things in a little bit more detail. And food supply and sustenance, initially you had to take food, and in the long time you have to generate it. Because lack of time, we are not going into the details, but people have worked out various options, how to do this cultivation in Mars, how to do terraforming, etc., etc. And then one major problem with respect to that is energy production. And you can depend on solar power, but Mars is fully dust-ridden. So the effectiveness of the solar powers is always a question with respect to the surface area, etc. But people have actually worked out for the same purpose very effective compact nuclear power plants. And people, NASA, for example, have developed such systems which can be used in Mars. It can be taken and used. So one major potential things will be, potential source of power will be that of nuclear power. Now, but long term, you cannot basically live in this fashion. You cannot live in the cocoon. So the long-term thing is you have to convert Mars to something that of Earth. This is basically what we call the terraforming. So you have to heat the Mars so that the Mars releases more greenhouse gases. So when you have more greenhouse gases, what will happen? The heat, the temperature will gradually go up. Since Mars is on the lower side as far as temperature is concerned, the greenhouse effect is better for Mars. And then gradually what people can do is we will be able to sustain atmosphere in Mars. So we will be introducing, or the people will be introducing greenhouse gases, and then people may release the cyanobacteria to replicate the change of atmosphere within the Earth, and this blue-green algae or the cyanobacteria will absorb, or rather which will take in the carbon dioxide and gradually convert it into oxygen. So this is the way by which you can grow long-term convert Mars into a living thing. But the biggest challenge, in my opinion, will be even if we create an atmosphere in Mars, the Mars don't have a magnetic field. So what will happen is the solar particles, the high-speed solar particles from the sun will tear away all this atmosphere. Okay, the Earth is having an atmosphere only because Earth is having a magnetic field. The biggest challenge in Mars will be to create an artificial magnitude by placing powerful electromagnetic Lagrangian points. So this is not that simple as it seems. So, but in the long term, when technology comes up, all these things will be possible, and communication systems have to be laser based because you may have to transfer data at a very high rate to have continuous communication, which to a preliminary form of which is already used by Starlink. This I won't go into the details, but the ECLSS, that is the environment control and life support, is one of the key elements in any such habitat-based systems outside the Earth. So we know exactly what is the typical amount of consumption of food, water, oxygen, etc. for per person, and people have taken calculate, or they have done calculation for say how much amount of energy, how much amount of food, water, etc. is required for 1,000 people per year, and they have worked out systems by which it can actually be made, recycled and reused, and with the amount of resources which is available on Mars and the energy which is available on Mars. And the last part will be, what are the present proposals we have? Okay, so the present proposals, which many of them are, because the Mars, many of them are things are engineering point of it's possible. The hindering part will be one, of course, is the cost. The huge amount of cost is involved, and humans, even though technically they are capable, psychologically there is a big question how much amount of stress they will be able to handle in these kind of missions, the sense of isolation and all these associated issues coming with doing such a challenging mission, that it can be the real deal breaker. Now, for the first time, I'm talking about the future plans. There is something called a lunar gateway. This is the first space station beyond Earth's orbit. So this is supposed to be in the cislunar orbit. This will be an outpost for future mission to Mars. And this case is very well known. The SpaceX is having plans. It's an active plan. It's not a proposal. They are having active plans to colonize Mars. And the SpaceX CEO wants to have almost 1 million people on Mars by the end of this century. They already have a launch vehicle. That's very important. They already have a launch vehicle which can transport as high as 100 tons to Mars as a cargo. And then the total cost, it is to be brought down to such a level that even if you pay 1 crore rupees, maybe at the end of this decade, you will be able to go to Mars. And this is the vehicle. I don't have to explain to this. Is well known. They are doing the flight test, and the last few tests has been extremely successful. And then there is an extremely high probability that this vehicle will be going to Mars, at least in the uncrewed version in the near future. So the first part is already covered. There is a high thrust vehicle which can take a significant amount of payload to Mars, and then it can actually land and it can come back. So the next, as a first step, they are not going directly to Mars, they are going directly to Moon. So how does it go? First, the Starship will go around the Earth, 2 Starships will be launched, then they will be having a fuel exchange. The oxygen and the methane will be transferred to from one to the other, and the second one will go to Mars, and then it will, after the mission, it will take off from Moon and come back. So in the lunar mission, whatever fuel and oxidizer it takes towards the Moon is sufficient for it to come back. Okay, but if you take the Mars, it's not that easy, because for a Mars mission, similar methodology is adopted from the Earth orbit. So the same Starship, multiple Starship will be launched. Then from the Earth's orbit, carbon, methane, and oxygen will be transported into the second Starship, which will be going towards the Mars, and it will be landing on Mars. But the problem is, by the time all the fuel and oxidizer will be gone. So what it will do? It will take carbon dioxide from the atmosphere, Martian atmosphere. It will take water from the Martian atmosphere. It will do what you call the Sabatier reactor. So it will split water into hydrogen and oxygen, and that oxygen will be used to develop the propellant, and then using the same methane and oxygen, it will come back to Earth. So this is the audacious plan of SpaceX. And they want to have this plan started as early as 2026. If their initial launches are successful, the first launches will be in 2026, and 2027 itself, they will be starting the human space missions to Mars. And gradually, over the period of the next 30-40 years, the entire Martian colony will be set up, and the parallel activities to do the terraforming will be going on in parallel. Okay, so these are the active plans to colonize the Martian environment. So I'm not saying that it's not a talk to advocate for interplanetary travel. It's not a talk to advocate for missions outside there, but these are the options people are considering and people are studying. And when you have the money, when you have the political support, when you have the technology, everything is possible. Now, what we have just discussed at this particular point of time. For the first time in the history of human civilization, building sustainable habitats outside Earth is possible. And if you're talking from human beings' long-term survivability, it seems like a necessity. Then we have advances in life support system, resources, and then one major thing which can be again a deal breaker is you require a very, very long term commitment. You cannot send some people and then stop this project. It's a very long term commitment. And then partnership between nations are very important. Private companies have to be involved. And most importantly, you are basically taking commercially fair paying people. So these people should have the money. They should be ready to go to Mars and then forget about Earth practically. And they have to be citizens of another solar system. Yeah. The last, yeah, I'm almost through. And so creating a thriving presence beyond Earth secures our species future. So this is the idealistic argument for sustainability somewhere outside. But of course, this presents only one part of it. The other side is definitely there are strong arguments against such things. One is with the kind of effort, money and all, you can make life on Earth 10 times more better, 10 times more inclusive, 10 times more comfortable for all the human beings. And the next argument is it basically many of the risk involved on life on Earth is still there on life on Mars or any other planet. And the kind of cooperation, commitment on the long term may be extremely unlikely. And the last thing is it basically helps the survival of certain members of human species who can sustain and who can pay for these kind of things. Okay, so these are the arguments on either side. So I have just taken, I think, exactly 20 minutes. So I will stop at this particular point. If there are any questions, we can discuss it further.
Yeah. Thank you, sir. On behalf of everyone here and SSA 200 chapter, I would like to extend our heartfelt thanks to the guest speaker, Sri Sheeju Chandran, for such an enlightening and thought-provoking talk on human habitats beyond Earth. And your insights into future of space exploration and the possibilities and challenges for the life beyond our planet, especially on Mars, as a case you have explained, has sparked curiosity and excitement in all of us. And a big thank you to all the attendees for being part of the 9th Talk of Plenty in 20 Talk series organized by SSI Trivandrum chapter. Participants are welcome to submit questions in the chat box, and few of them will be answered by the guest speaker as the time permits.
Can we ask direct question also?
Yeah, actually, already chat box 1 or 2 questions are there.
Yeah, you can post your questions in the chat box, and we can ask them.
Okay.
Sir, Sheeju sir.
Yes.
Sir, one question is our body is tuned for 1G. How long we can survive in Mars?
Yeah. Even though our body is actually tuned for 1G, our body can sustain much higher Gs and much lower Gs. Okay, so it is not impossible for a person to survive in say 0.4G or 0.5G, provided that adaptation is slow and gradual. Okay, so that is the key. So even with the there are certain conditions our human body cannot tolerate. See, for example, extreme temperature ranges, extremely low concentration of oxygen, similarly extremely high concentration of carbon dioxide. These are basically a problem. But 0.4G kind of a thing, it's not something which is very, very difficult, because as you're aware, people have already gone to the moon. They have been adapted to that kind of environment. Even in space, people live in 0G kind of an environment. So long-term adaptability, the biggest problem is, you very well know that there is something called osteoporosis. That is basically when your body senses that you are at a lower G, that means that you require less amount of inertial force. That means your muscles don't have to be that much stronger. If you want to lift something in a 0.4G condition, your muscle have to exert only less amount of force. And because of that, the body will start dissolving the calcium carbonate in your body, and you will eventually become very, very weak, and your muscles also will be losing strength. So that is a irreversible process. So what you may have to do when you go to environments like in zero G condition or lower G conditions, you have to maintain your health and your muscle strength, and the lack you have to avoid osteoporosis by continuously doing exercise. So something which you take it for granted on earth, you have to do extra work even to maintain that level. So significant part of your life in any other planet other than 1G condition, you have to spend on exercising, building up your muscle strength, and ensuring that your body doesn't go for these kind of calcium carbonate dissolution. So it's not impossible or difficult, but we have to take appropriate mitigation action.
Okay, thank you, sir. Sir, next question. Instead of searching alternative habitats on other planets, why not we focus on Arctic and Antarctic continents, more habitable for humans?
Yeah, but the Arctic and Antarctic is very well part of our habitat and ecosystem. The moment you go to Arctic, and if you try to melt the glaciers to have a more sustainable thing, it affects the other part of our own planet Earth. Okay, so that is the biggest thing. And second thing is, if there is an overcrowding on certain locations and parts of the earth, going to other parts of the earth is definitely an option. But we are talking about existential threat on the planet Earth, right? If your argument is to address the existential threat on the planet Earth, you have to go out. And you may be knowing now, almost 50 to 60% of the entire Earth population lives in a very small circle in and around India, China, Indonesia, Philippines, Bangladesh, that side. So all other, even though from an Indian perspective or a Chinese perspective or a Bangladeshi perspective, it seems too much crowded. If you travel outside these places, Earth is pretty, you can say, sparsely populated. So the problem is not exactly on distribution of population within the Earth. That is always possible. And there are so many places of Earth which can be made habitable, like Sahara, for example. It's definitely be there. But if you touch places like, say, the Amazon for the rainforest or Antarctica or Arctic, that will affect the ecosystem per se. But you can always try other places like, of course, Sahara, make them habitable. Much with the effort of terraforming in Mars, you can convert the deserts in Sahara into plant. That's perfectly fine. It can be done. But what we are primarily discussing is, if you have threats on Earth, what are the options outside Earth?
Okay, thank you, sir. The next question is whether Titan option is still considered by any agency.
Titan is considered. I think I have shown you. I did not dwell upon it because of lack of time. Titan and Callisto and many other Jovian and Saturnian satellites are considered. But the only problem is they have a very good atmosphere. They have much better conditions as far as humans are concerned. But the biggest problem is they are very, very, very far off. So if you have any kind of dependence you are planning to have it in with respect to Earth, that is not an immediate option. So there is one thing which we missed, or rather when in many of the arguments, see, now you can see with the AI, ML and the kind of advanced robotics, even to a Mars mission for the initial couple of generations, you don't even have to send humans. You can build the colony, you can make this initial terraforming, you can do all this kind of necessary environments of humans can be created artificially by robot even before the first humans can come in, right? So these are the options as far as the Titan, Callisto and other systems are concerned. Titan is definitely a good choice because it is having a very high nitrogen-rich atmosphere, and pressure is more or less similar to that of the surface liquids of methane, ethane, and other organic compounds are there. So there is a possibility. But the issue is, again, the problem is if you want to go to Earth, or rather if you want to go to Titan, from here it takes almost 7 years. Okay, so 7 years, too long a time period for a person who is en route to change its plan, changes even the decision. It's from the present mindset of an average human or an extremely capable human, these kind of things are very, very challenging. So if you have unless we devise some methods to shorten this travel time from 7 years to a couple of months or so by some advanced technology in near future, these kind of large travel time to conquer the distance is a very big points against that. So that's why I said in the short term, it seems to be Mars or Moon. Long term, we don't know when the technology gets developed. There are so many other options.
Thank you, sir. So then this existential threats are applicable to Mars also. So how we are going to handle that?
That I told, that is the biggest argument against going to Mars. But here the other way of looking at it is something like redundancy. See, suppose if you say that if one system can fail, even when there is one more, the first can fail. if you take the analogy for adults. But the point is the second one is there. Okay, so similarly, if you are basically talking about the survivability of humans as a race or as a species, your chance of surviving is much more when you are having when you have your presence in 2 planets or more. Right. So that is the way by which you have to look at it. So if the humans are living on Earth, humans are living on Mars, humans maybe if they are living on Callisto. So that means even if in one place it is getting destroyed, the human race can continue. Maybe after some more time they can come back to Earth again, repopulate it. So that is the way it's being looked at.
Thank you, sir. I think with this, we have reached the end of this talk. And big thank you to sir and all attendees once again. And see you all in the next talk. Thank you.
Thank you.